Dear audience, my name is Jan Matsuya, and I'm going to familiarize you with the challenge number 11 from smart points of interest towards sustainable points of interest. While we are talking about the theme, it's good to clarify what is espoi in the first place. Well, espoi is an abbreviation and it comes from the name smart points of interest. Smart points of interest. What is that? It's a global and seamless database of points of interest. Point of interest is what? Well, it can be generally anything, not necessarily a real point. It can be also a large area, for example, a natural park, but it has to be to interest for someone. And in our case, we collect points of interest in the domain of tourism, transportation, regional development, urban planning, and similar areas. The current version of espoi database contains something around 30 million points of interest. These points of interest are widespread around the globe. It lies in more than 200 countries, and the data comes from 14 different data sources. Now, the goals of our challenge were following. We needed to create a new and robust maintainable pipeline to create this database and to create it from the OSM, which is OpenStreetMap. Another objective was to identify sustainability options and to propose some business models to ensure that the espoi database can be continually maintained and developed. And we also looked at the areas where espoi can be used and integrated with other third-party data sources. The team behind challenge number 11 consisted of the mentors, which was me and Rune Bergheim, and 4 registered participants, Daniel Kunicki, Raul Palma, Michal Kepka, and Karel Charvat. You probably already know these names from the other challenges of this hackathon. I'm now going to sum up some of our results and some obstacles we dealt with. The first scope of our challenge was the extraction and transformation of the data from open data sources to data model of espoi. The current harmonization process is displayed on the screen, and it's quite complex already. Each of these stacks represent one data source, and together they form the espoi database. Most of these processes were one-time, while some others can be repeated. The problem with this harmonization is that the process is not really error-prone. We have found already many mistakes in the database. Some include, for example, inconsistent property ranges, like on the screen on the left, some random errors, like errors in spelling and letter casing, and also creation of duplicate points of interest, which is caused by the integration from different data sources. Therefore, it is evident that we need to create a new process of extraction and transformation of data, which will address these side effects and deal with them. For the beginning, we chose to only pick one data set, which is the OpenStreetMap, and that is because OpenStreetMap is nowadays the source of some 90% of our points of interest. So it has a very critical role in our database. We have investigated how to extract the data from OpenStreetMap, and from the options that are available, we have selected to pick a so-called planet dump, which is a seamless coverage, seamless data of the OpenStreetMap around the whole world. And we have selected the PBF binary format, which is concise in size and there are multiple tools which can handle it. From this extraction of data, we want to transform it into our data model and load it into our RDF database. So store it in a linked data format, RDF. The transformation process from PBF files to the RDF database is still to be developed. We have looked for some possibilities, but due to lack of know-how and people, we were not able to complete this transformation step, and it is still a challenge for us and our area of interest for the upcoming weeks and probably even months. Another important aspect of our challenge was to make the espoi dataset more accessible and attractive. So we formed a team that was improving our visualization of the data in a map application. This is the application, and I will briefly walk you through it. So this is how it looks like when the application starts. We have pre-selected some categories which might be interesting for the end user, categories of points of interest, and you can turn them on or turn them off one by one, depending on what does interest you right at the moment. You can also request all points from the database, all points that lie in the current map view, but this query to the database is a bit slow. It's expensive query, so I have preloaded the data for the purpose of this presentation. You can click on the individual points to get some information. It's a nice feature we have developed during this hackathon. So if I click on some of these features, you get information about the POI in a nice, pretty table. You get some basic properties about that POI, which might be useful, like a cuisine. In the case, it's a restaurant. You can get, for example, a contact for a hotel. There's a homepage link. So you can link between data, which is the core of the linked data principle. Now, if the points in the map are not self-describing to you, you can check the legend and see what is in the map. And you can do some other stuff. We also have a layer with weather forecast, for example, here. So you can check if there will be a cloud cover at the moment, if there will be some rain in the area, or what the temperature will be. You can, of course, change the background maps and some other stuff like adding your custom data, switching a language in case you need it, and so on. So this is the current version of our web map presentation we have improved. And I will move to the next topic. For this part of the hackathon, I give word to my colleague, Runar.
There are three different ways in which we seek to achieve data interoperability in the espoi data space. And depending on which business model is chosen going forward, some of these might be more relevant than others. For programmatic access over web, we have offered a Sparkle endpoint, which permits user customized queries on the whole body of the data, and a RESTful web service API that communicates via JSON for high performance services, which are at less risk of creating very high server load. For download and distribution, the surprisingly resilient and robust CSV format remains the preferred option, as it makes it very easy and compact to transport data between systems. And for access from applications in the GIS domain, we bank on the OGC web map standards, particularly WMS for raster data and WFS for sharing of vector features. The hackathon has also looked at business models for espoi going forward and arrived at 3 different levels of models. The first one being sustainability achieved through strategic partnerships, whereby espoi partners with one or more organizations that rely on espoi for their own service offerings in a non-competitive way, so that they do not mind sharing this data in the open database license regime with others. The second is to offer API services on a centralized instance of the espoi database, which allows third parties to build their own applications without copying or downloading data to their own infrastructure. The third one, which is the most complicated one, but also potentially one with the highest returns, is to offer our own set of end user services.
So that would be all from us. Thank you for your attention, and in case of any questions, don't hesitate to contact us.